India has officially introduced DHRUV64, the country's first fully homegrown 1.0 GHz 64-bit dual-core microprocessor. It is developed by C-DAC under the Microprocessor Development Programme. Why this story is making headlines everywhere? A microprocessor is a brain of an electronic device. It processes data and controls how the system works. Processors are not only for smartphones or laptops. They are the invisible brains powering almost every modern system, from cars, medical equipment, and industrial machines to satellites, defense systems, smart appliances, and critical communication networks, and the list hardly ends. India consumes nearly 20% of the world's microprocessor, but most of these are imported. DHRUV64 directly addresses this gap by providing a homegrown processor platform that Indian startups, research institutes, and industrial can build upon. Now let's deep dive in its features. First, 64-bit. Generally, there are two types of processors existing in computing, the 32-bit and 64-bit processors. A 64-bit processor can handle much larger chunks of information at one time compared to the older 32-bit. It can understand and process bigger numbers, more memory, and more complex tasks in a single go. Thus, 64-bit system can work faster, handle large applications smoothly, and use a lot more memory without slowing down. Second comes the dual core. A dual core processor is a single CPU that contains two independent processing units inside one chip. Both cores can process data at the same time. Each core has its own cache memory and its own controller. This means the two cores don't constantly wait for each other. They can handle different tasks simultaneously. As a result, performance improves, heat generation is reduced, and power efficiency gets better. Now third comes the 1.0 GHz, which means 1 billion cycles per second. It is a unit of frequency used to measure how fast electronic devices operate. This means the processor's clock ticks 1 billion times every second, which helps to process instruction very quickly. In simple terms, it shows how fast the processor can think and respond to that particular task. DHRUV64 also leverages RISC-V, which is an open instruction set architecture. That means there are no license fees to use it. Unlike proprietary architecture, this will allow Indian researchers, startups, universities, and companies to innovate freely without depending on foreign IP owners. Now let us see its advanced features. DHRUV64 uses superscalar execution, which means the processor can execute more than one instruction at a time in a single clock cycle. So instead of processing instruction one by one, it looks for independent instruction and runs them in parallel, which results in fast execution, better performance, and improved efficiency, especially during the heavy workloads. Another important feature is out-of-order execution. Normally, instructions are processed in a fixed sequence, but DHRUV64 is smarter than that. It can rearrange instructions internally, completing whichever instructions are ready first. This keeps the processor busy at all times, which reduces waiting period and significantly improves overall throughput and responsiveness. Now, it also integrates communication and control functions directly on the chip. This reduces the need for external components and making system design simpler and more reliable. The processor uses FCBGA, that is flip chip ball grid array packaging, which improves electrical performance, heat dissipation, and compactness. In simple terms, this makes DHRUV64 robust, compact, and ready for deployment across a wide range of systems. Now let us see its target application. Technically, it is designed for deployment across multiple domains, which includes 5G and telecom infrastructure, automotive electronic system, industrial automation, consumer electronics, and IoT gateways and edge computing. DHRUV64 does not exist in isolation. It builds upon earlier indigenous processor efforts such as Shakti from IIT Madras, Ajit from IIT Bombay, Vikram from ISRO and SCL, Tejas 32 and Tejas 64 from C-DAC. Together, these processors form the backbone of Indian processor ecosystem rather than an isolated project. Thanks for watching this video.